Thanks everybody for joining. This is the concluding session on that agentic theme that I've been running. I have recorded all the sessions in case you have missed previous one. I would be sending those links after this series completion. Today we are going to focus on Microsoft Agent Framework. Uh, as you know, this series is essentially around Agentic AI, and we have covered MCP, which is more of an integration technology. We covered AI Foundry, which is a platform that Microsoft offers where you can do virtually everything that is related to AI, machine learning, data science. Today, we are focusing on the, the agent aspect. What is there in the agent? How do you code it? Uh, Again, I would have concepts supported by demos. These sessions are meant for anybody who's interested. So it doesn't have to be, technical people. I'll take questions at the end. And I always say that these sessions are kept at a conceptual level for the wider audience benefit. And I try to give demos so that I'm not just talking, but also showing something really working. I can take this session to the next level if you want. I use Azure platform purely because of my background, but whatever I've been discussing as part of this series, it is agnostic to model, platform, languages. Most of them are using open source technologies. So if you have some other platform to work on, feel free. Whatever you're going to take out from this session is absolutely applicable on those platforms as well. This is a series I've been running for last couple of years now as a community give back and also remain connected with the network. That's the only thing I can do. So let's begin today's session, and I just want to highlight something which is I firmly believe in. So you would have seen a lot of limelight these days. Nvidia becoming the largest company from market cap perspective. It's a $5 trillion company. Then you have OpenAI, Meta. All these big players are making investment, making big moves. But there's a bigger opportunity which exists at the application layer, and that's basically where I operate, and most of us are not in building platform models and everything. So as per Andrew Ng, who's a very knowledgeable person, he's worked in Google. Now he runs a deep learning.ai, which is a very good platform for you to do some sort of a learning on AI. So he's saying the opportunity is bigger in the application space, and that's what we want to really focus on. Now, we are talking about agents. So we have no agents, which is essentially what you have been working on if you're using ChatGPT, Claude Desktop. So you have an interaction, which is one shot, ask a question, you get an answer, you may ask a follow-up question or ask another question. Agents take that discourse to the next level, and we'll see how that is enabled through those agentic frameworks, where you can actually provide a task to the agent, and the agent has access to tools, can do research, call APIs, and then work iteratively to accomplish the goal or the task. And that's really very useful because agents can reason, and we'll see how agent has this capability of reasoning and how they basically do much more than just calling and interacting with an LLM. Now you can also take this to the next level by introducing multiple agents. So there is a need for specialization where you have a complex task that has to be dealt with in specific ways, where you want some specialized capabilities as part of executing the task, and that's where you build multiple agents. And I'll also show you why we need multiple agents. So let's understand what is an agent. Now, we all know we have LLMs, large language models, small language models, and they have good intelligence, which is artificially injected by training them on, you know, a big data set. So that's fine. That has been the trend. Now, what agents does through some framework, they bring the reasoning, planning, execution capabilities. And if you provide access to the agent in the form of tools and resources and instruction or prompts, they can do really very well, and they can really perform a lot of things autonomously. And maybe if you have a critical task, you can bring human in the loop. But essentially, what is happening that agents become some sort of a capability which can carry out a lot of things, thinking, planning, executing, reasoning, orchestrating of its own. That leaves a lot of drudgery out of people who are working on some critical area. And we'll see. Multi-agent, again, takes it to the next level where you can create agents and sub-agents. Uh, so sub-agents, basically, they specialize in a specific part of the task or goal. Uh, the reason this is going to become really useful because you can have an agent specialized with set of tools provided, information in the form of knowledge, and specific instruction for the subtask. And you can create as many agents you want based on your requirements. And this sounds very similar to microservices architecture, where you have an orchestrator, which is basically coordinating among different services by calling them in an orchestrative way. Here, um, the the intelligence also adds value, whereby a lot of things can happen autonomously. That's basically the benefit of having agents. Now, how the agents work. So what you require is an agent framework, which is nothing but a software development kit, or a software framework that enables the orchestration where agent can actually uh, reason, learn, observe, carry out some task, check the results, and then achieve the outcome iteratively. So Microsoft has recently introduced Microsoft Agent Framework. Microsoft had two frameworks already, AutoGen and Semantic Kernel. So they rationalized their product because these two older frameworks um, originated from two different business units within Microsoft. Uh, AutoGen is from Microsoft Research. Semantic Kernel is a normal, product development team. What basically does, just simplifies things for people like us. So we have to deal with one framework, and what it offers is basically the ability for you to write agentic applications locally and then make use of platform like Azure AI Foundry. It is well integrated and ingrained with their platform. And then you can leverage the capability in terms of observability, durability, and compliance, which is of a high importance in enterprise scenarios like we work on. It can integrate with any API using Open API, what was called a Swagger uh, interface specs. It supports agent-to-agent protocol. So agent-to-agent protocol is the protocol where multiple agents can talk and collaborate with each other. These agents can be developed, deployed anywhere with any language, any framework. So this is a framework that Google has uh, created. And you can also leverage model context protocol, which was the first session where you can actually very swiftly and efficiently connect to different tools, resources, and prompts without having to do much. Microsoft also had a Magentic one framework. It basically can leverage that capability, helps reduce the context switching, and can connect to, like I mentioned, Azure AI Foundry. Microsoft 365 Copilot, and other agents which are written in any other platform. So what the Microsoft Agent Framework offers is two types of constructs, what is called AI agent and workflows. Now, most of us have been working in this industry for long, and we understand what is a workflow. It's set of operation that you carry out one after the other, where output of was first step goes into the second, and that's it. So workflows are not new. It is called business process management, automation. What has happened now? Some of the task and all of the task in the workflow can be agenting, and that's is all about workflow. Let's spend some time on AI agents, which are really uh, important. So what you have basically an agent backed with an LLM. The mind and the intelligence come from a language model, and what it has: tools, resources. The tools are the actions that agent can perform based on the context. Um, Resources or knowledge sources are the underlying grounding data that agent may need. Although LLMs have vast amount of an data they are trained on, but in enterprise setup, purely because the data may not be correct, it could be misinformation, disinformation. So you would like to supply your own data or an organization private data, or the data from online applications that any model would not know about. So that's basically agent can deal with. And then obviously you provide instruction in terms of how the agent should behave, uh, what how you want the output, anything specific that would be useful for agent to become a persona. Let's say you want to build an agent which is providing help in terms of medical domain, or you want to have an agent behave like a travel agent. So all that goes in terms of the agent definition, and we'll see both AI agents and workflow. I mentioned Microsoft has built um, a great platform called AI Foundry, which has everything to do with AI, machine learning, data science, agentic AI, and you probably um, have seen that in my second session. In case you missed it, I would be sharing the recording so you can go through that. So what basically this multi-agent uh, framework on Air Foundry offers you is kind of a no-code solution where you can actually create an agent by just clicking some buttons, providing an LLM instruction, connecting it to tool or knowledge sources, and that's it. That agent is exposed as an API, so that means you build it on AI Foundry and then run it there, um, and that's it. So we'll see agent development today. Microsoft also offers you some sort of a graphical user interface or a workflow designer through a Visual Studio extension for you to really create it in a drag route manner in case you need. We'll see if we have time to. Now, applications are great, but we want it to be observable. We want to have the explainability, what is happening, why it is happening. And that's where Microsoft adopted what is called an open telemetry framework, which is the telemetry aspect uh, for any application that you build, so that you can actually not only debug, optimize, but also be compliant. It will give you logs and some sort of a near real time metrics for you to really observe and see how your application is behaving. And that is very important, especially when we are talking about enterprise applications. Now, let's see how internally an agent works. Um, so we have a user message sent to an application which is agentic. And what it basically does, it sends the request and try to understand, leveraging the language model, what it needs to do in order to accomplish the task. And that is basically um, done by calling an LLM. And what LLM is going to provide based on the context is that this looks like you have these many tools. And this instance, you should be calling a particular tool with this uh, parameters. That is basically what is called tool calling. And that is when the agent would make a call to another agent or a tool or leverage MCP and then get a result back, which is a tool result, which will be finally fed uh, to the LLM to generate the final response. Now, this portion can be iterative depending on the complexity of the task that user has provided. If the task requires multiple steps, the agent will do the orchestration, call the appropriate tools in a specific order, could be concurrent execution or a sequel execution, and then aggregate the results, reason over it. If required something else to be done, then it will carry out the task, and then final context is provided to the LLM, and you get the response back. So one single call, agent is doing everything. And if you've done prompt chaining yourself, you ask a question, and then based on the result, you ask another question. Human being are doing the reasoning and orchestrating. That task is then in an agentic app is taken care by the agent, and you can bring in a human in the loop in order to be sure if it is a critical task. On the similar line, you have a workflow agent, uh, which is nothing but a sequential flow. I mean, there are different options. You can have concurrent flow also, but essentially, this is like a Unix pipeline. You initiate a task, agent does something, the result is handed over after processing to the second agent carried out something, does reasoning, and may call a function or call another agent, and the final output is then sent back. So this is sort of a stateful process of orchestration or automation. Uh, Very similar, but the main difference here is, unlike uh, the agentic orchestration, which is mostly autonomous. So what you provide agent all the required tools, resources, and instructions, and it chalks out what needs to be done. But in cases where you have a business process to be executed with a bit of automation or AI, you want it to be running in a specific order, and that's where um, this workflow will be useful. Now, you may have a combination of that also, depending on your requirement, but these are the two common patterns. So that's pretty much the concept. So let me just go to the demo. Um, and I am purposely creating an understanding of how easily one can code if you know any language. So Microsoft Agent Framework is available in C# and Python for the time being, and I'm very sure they'll introduce JavaScript and other languages soon. So what you have here is just a definition of the agent. So if you see here, I have connected agent to an LLM. These are the configuration that you require to connect to an endpoint, which is uh, OpenAI model uh, on Azure. You provide the instruction. You are a helpful assistant. You can provide any additional information for agent to behave it in certain way. Give a name of the agent, and that's it. So this is just a loop. Okay, and practically the agent without tools and other things is of no use, but I'm just trying to show you here how easily one can. So it is essentially one line of code, okay, and other is nothing but a loop. Okay, so let's run it, and let me just tell you what is the purpose of showing an agent without any tool and all. So you ask anything, hi, it'll give you an answer. It's very similar to Chat GPT or any other. Now we really want this to be a proper agent, and that is what is here. So it's the same agent. I'll come here, and what I've done, if you see the additional line, which is two tools that have been provided uh, to the agent. Now agent has tools. What are these tools? These tools are nothing but uh, two APIs or two functions, which in turn calls a weather API and a flight in details or flight information API. This is the real API that I'm calling. And now this agent is capable, and it is basically able to reason based on the request that I provide what tool to call, and when it decides based on the context or the prompt what tool to call, it also creates the parameters based on the definition for the tools that is here. Okay, and this is where it really becomes an agent, and let's see how it works. So now this is chat tools. So now I'm running this code. So this is an agent, and it has access to two tools, which are, I mean, two endpoints that I'm calling. Let's say I want to ask, what's the weather in Sydney? Now I have not coded anything, or I have not programmed this code to be working in a specific way. That is what traditionally we have been doing in terms of incorporating an algorithm in your program or a logic in this program. So I'm asking the agent of the weather in Sydney. What it is doing is basically understanding, inferring what is the ask. It is a very simple task for just showing you the internals, and then it goes, makes a call, and gets you the results. And that's it. Okay. Now let's try something else. And it'll do the same thing. We can ask uh, what are the flights between Sydney and Brisbane. Now it is calling that flight, aviation stack API, and that's it. So you are basically now enabling the tool use. Probably if you just go and do the same thing in the chat GPT, if it is not enabled with web search, you will not get the response like this. Now just imagine you can connect it to any enterprise system that you have, carry out anything. You can also retrieve information by having an appropriate retrieval tool, and that's how you do that. So that's basically, an agent with the tools. In enterprise setup, you may like to have an approval process. So what I've done, just added some layer, and what happens here, um, in case you want that agent to be working based on the approval from the user, you want to keep the human in the loop purely for safety reason, and you want to make sure that um, the application or the agent doesn't do anything um, wrong. So let's ask it again and see how. Um, let's ask for Now see what happens. And now you can actually see what goes behind the scene here. Based on the input, the agent is inferring that I need to call a get weather function, okay, or get weather tool. And the argument or the parameter that I have to provide, because it's an API call, it has to give as a request body city and name of the city, name value pair, and it's asking for your approval and if you want. So this is very useful in case if you have some critical operation or you have some action that will have consequences and you really want to control or bring you human in the loop. And that's basically. Now we've seen an agent, and if you remember, I've shown you a multi-agent uh, architecture also. So what I've done here, I've extended the same application where I've actually created two more agents, sub-agents, same tools, same APIs. So I've created a weather agent and a flight agent. Okay, in this case, is not required because the main agent is capable of doing something. But in order to show you how a multi-agent architecture would work and why would it be useful as compared to a single agent, maybe probably that's a question which may come in your mind. So what you see here, in a single agent, I can assign the agent one large language model or an AI model, and I can provide one instruction set. Whereas if I have a complex task where each part of the task requires some sort of a specialization, it may need a specific GenAI model which is built for that purpose. So I have the ability now to provide in a different model. I'm using the same model here, but I can actually configure weather agent to use a weather model. Okay, uh, a flight agent to use a model which is purposely built or tuned for that. Specify uh, instruction which is specific to that subtask, and then assign one or more tools. You can basically have an hierarchy, and that's the value a multi-agent uh, system would have. And then the main agent, if you see here, very similar. I'm providing the instruction how it is going to be working, and it will have access to the two sub-agents as the tools. That's basically the difference. And it'll do the same thing. Let's run it. But the point was to just demonstrate what is this name? Chat. So you may have a requirement where the nature of the task is uh, complex, and what this main agent is doing here, it is basically orchestrating. So sorry. So we ask this, and let's see what happens. Now the supervisor agent is likely a router or an orchestrator, and then what basically does, it knows that this is related to the weather, and it will basically hand over that information to the sub-agent, which is expert in weather or any other task, and that weather agent will perform the task and give you the result. On the same line, let's say, if I have something, maybe, yeah. So let's say we are asking, so supervisor agent routes it to, so See what is happening. It's an agent calling an agent, and in turn, that sub agent is making use of the tool that we have seen in, and that's pretty much. So let me go back and see where are we. So that's basically was the purpose of giving you an understanding how agents can be created very easily. Now you'll probably see a lot of uh, platform offering you a sort of a no code, including Microsoft, where you can actually create these agents. But the purpose of this session is to give you the insight, and it's not really a rocket science. So let me go back. Uh, what I'll do now, I will uh, take you to the concepts of workflow. They are not new. It is just that we have basically the GenAI aspect. So um, we have different types of workflow. Um, yeah. So workflow is nothing but um, number of steps which can run parallelly or sequentially. So there are 4 types of orchestrations which are supported. One is the sequential. The first one, you have an agent calling another agent with the output that it has produced, and likewise we have concurrent. If you have your subtask independent of other tasks, then you can run it concurrently. So this is going to act like a dispatcher or distributor, where it'll provide the required inputs to the agents, and then at end of it you collect and aggregate the response to create the final outcome. You have also a pattern called handoff. Sometimes based on some condition, you want to hand it off to either human being or some other agent, and you can achieve it in workflow. So workflow is much more tighter in terms of control. So they have concept called Magentic framework, where you basically assign a task and it carries out, it creates a task list, what needs to be carried out, and then there's a progress and it is kind of working autonomously achieve the outcome. So these are basically the different patterns that are supported in Agent Framework. Now, Microsoft Agent Framework is not something which is very unique. So there has been numerous agentic framework. Uh, um, Two of them were from Microsoft bag. There was one called LangChain, LangGraph, N8N, LangFlow. So there are numerous, and I've happens to work and evaluated all of them. Uh, my um, conclusion is they are not very different. So you can choose any of the framework that you're comfortable with. All of them supports Python. Microsoft frameworks definitely support C# as well. Um, but what is important beside the agentic framework, you need a platform and other capabilities in terms of responsible AI observability in order to really make an enterprise grade solution. So going back to the slide, um, so it's an SDK that combines the capabilities of the earlier frameworks, supports .NET and .NET, which is C# and Python, gives you capabilities like observability and all, and that's it. You can really build um, good enterprise grade applications, and that's where Microsoft scores over other frameworks. Although Microsoft Agent Framework is also an open source, but it is kind of backed up by Azure platform and other Microsoft services that becomes very easy. And I was talking to a couple of folks. Microsoft ecosystem is well integrated, unlike other um, platforms. and it may not be the best um, in parts, but overall that integration with the ecosystem is really very useful. Um, the security, identity access management, other traditional IT services like databases, SharePoints, and all that really makes it great. I happens to be a Microsoft guy for the last 25 years, and now I'm working with Microsoft. It is much easier for me now to really go and offer something more practical and more useful to my clients, my team, and I enjoy doing that now a bit more than what it was there. So that's pretty much I have. I'll stop